So here we go with 21.1. I'm actually going to split this up into two videos. Today we're going to do 21.1a, which is the first page in your notes packet, and tomorrow we'll do 21.1b, which is going to be the second page. So for today I'm just going to do this page right here. Now, we're going to talk about probability distributions. We talked about distributions a bit previously with line plots, also known as dot plots, also with histograms down there. And we did frequency distributions for the most part. Now we're going to talk about probability. Now most of you have some idea of what probability is. So suppose you perform an experiment consisting of a certain number of trials, maybe flipping a coin, which we'll talk about here. The experimental probability of something happening is equal to the number of trials where it happens over the total number of trials. And this notation right here you're going to see sometimes, and that means probability. So P and then parentheses something means probability. So we're going to be dealing with fractions, so you must remember to always reduce in your final answer. So you must always, always, always reduce. So let's look at a quick example of regular probability here. If you tossed a coin 100 times and it actually turned up heads, there's the bell. If you tossed a coin 100 times and it actually turned up heads 45 times and tails 55 times, the probability of flipping heads, I would put the number of times you got heads over the total number of times, and then I would reduce my fraction from there. That ends up reducing to 9 over 20. Now, sometimes you might see this written as a percent, and to get a percent, that one happens to be 45%. But to get a percent, you would just do either 45 divided by 100, or you could do the 9 divided by 20. Either way, you get 0.45, and that means 45%. Remember, you move the decimal twice for percents. So what about tails? Tails you flip 55 times out of 100 possible times, and 55 over 100 is 0.55. Let me change that to a fraction. That's 11 over 20. That would be it as a fraction, or sometimes you might see it as the 0.55, which is 55%. So that's our basic probability right there. So that was experimental probability, and the reason why that's experimental probability is because it's like you're doing an experiment. You actually tossed the coin 100 times, and these were the results. Now, experimental probability has a counterpart, and that is called theoretical probability. So theoretical probability is what should happen based on what you know. So for example, if you have a coin and you tossed it 100 times, theoretically it should come out half the time as heads and half the time as tails. Experimentally it might not, because when you actually flip it 100 times you might not get exactly 50 of each. But theoretically is supposedly what should happen. So suppose a procedure can result in n equally likely outcomes. For example, the coin toss, we would have two equally likely outcomes, one being heads, one being tails. If an event A corresponds to m of those outcomes, then the theoretical probability of that event, so the theoretical probability, for example, of getting heads, would be m over n, which is the number of possibilities where heads is flipped, over the total number of possible outcomes. So let's do some theoretical probability here. The probability of flipping heads when you are flipping a coin, that would be 1/2. Because if you flipped a coin, one of the possibilities, one side is heads, and there are two sides possible. The probability of rolling 3 on a dice, if you think about a dice has sides 1 through 6. One of those sides has a 3. 6 sides are possible total. The probability of rolling a number less than 4 on a die. Well, less than 4 would be 1, 2, or 3. Notice it doesn't say less than or equal to 4. If it said less than or equal to 4, I would have to include 4 on that as well. So that means I have to find the probability of rolling a 1, which is one side out of the 6. I'm going to add it to the roll of a 2, which is another 1/6, and the roll of a 3, which is another 1/6. Now there's another way you could think about it. You could think about the fact that this is 1 side, 2 side, 3 sides out of the 6 sides total. So you can either add up each of the individual ones, or you could add them up over here. Either way, that ends up giving you a 1 in 2 probability, or a 50% probability of rolling a number less than a 4. The probability of rolling at least a 3. Now, at least a 3 means anything 3 or higher. So that would be 3, 4, 5, or 6. How many is that? That is 1, 2, 3, 4 of the sides of the 6 sides on the die will meet that requirement of being at least a 3. So if I reduce that, I get 2/3. So again, these are all theoretical probabilities. If I actually rolled a die, I might not get 4 out of 6 rolls equaling at least a 3, because experimentally it doesn't always work out that way. The probability of drawing a king from a deck of 52 cards. That would be our playing cards, where you have 4 suits, hearts, diamonds, clubs, and spades. Probability of drawing a king. There are 4 kings in that deck of 52 cards, so I would have 4 over 52, and that reduces to 1 out of 13. So that would be my probability of drawing a king from a deck of 52 cards. So like I said over here, you can either add up each of the possibilities, 1/6 plus 1/6 plus 1/6, that ends up giving you 3/6, or you could add up the possibilities, this is 1 of the sides, 2 of the sides, 3 of the sides, and put it over 6 and reduce it from there. That's what we call cumulative probability. If you want the probability that a random variable is less than, greater than, less than or equal to, greater than or equal to, at least, at most, all of those guys, you add all of the probabilities that fit that particular outcome that you're looking for. So that's what we're dealing right here. A random variable is a variable whose value is determined by the outcome of a probability experiment. We'll talk more about that in a little bit. And a probability distribution is the distribution that gives the probabilities of the values of random variables. So let's take this whole idea of rolling a dice a little bit further. Just one die, we're going to roll it, we're going to roll it twice. If 2 die are rolled, the possible outcomes are, sorry about that, if 2 dice are rolled, then the possible outcomes are this. Now you would roll 1 dice first, and then you would roll a second dice. So this is saying that the first time you rolled the die, you rolled a 1, and then you picked up the dice and you rolled it again and you rolled another 1. This point down here says that the first time you rolled the die, you got a 4. Then when you picked it up and rolled it again, you got a 5. These are all of our possibilities. So if you rolled a 1 first, your second roll could have either been a 1, a 2, a 3, a 4, a 5, or a 6. If you rolled a 2 first, your second roll could be a 1, a 2, a 3, a 4, a 5, or a 6. If you rolled a 3 first, your second roll could have been a 1, 2, 3, 4, 5, or 6, and so on up to 6. Now, how many possibilities are there? There are 1, 2, 3, 4, 5, 6 by 6. There are 36 possibilities there. Okay? We're going to show, let's see, I'm going to come back over there. So, first thing we're going to do is we're going to make a histogram of this probability distribution. So we're going to find some information out here. First thing I want to do is find the absolute value of all the possible differences and complete the table. Now when I say difference, I mean, what is 1 minus 1? That's 0. What's 2 minus 1? 1. 3 minus 1? 4 minus 1? 5 minus 1? 6 minus 1? Can I have any differences that are bigger than 5? 1 minus 2, we're only going to talk about the absolute values, so the positive ones. So the difference between those two we would say is 1. 0, 1. Those are 2 apart from each other. Those are 3 apart from each other. Those are 4 apart from each other. Those are all numbers I've got here. Those are 2 apart from another, 1 apart, 0 apart, 1 apart, 2 apart, and 3 apart. So again, you're just taking the bigger number and subtracting the smaller one. 4 minus 1 is 3, that's on my list. 4 minus 2 is 2, that's on my list. 4 minus 3 is 1, that's on my list. 4 minus 4 is 0, that's on my list. All of these, if I were to subtract the bigger number minus the smaller number, are going to give me one of those results. Okay, so here's what I'm going to fill out now, the frequency. I want to know how many times would I do a subtraction and get 0 as a result. Well, the only time I can get 0 when I subtract is if I'm taking a number and subtracting the exact same number. So that would happen on 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. How many is that? 1, 2, 3, 4, 5, 6. That happens 6 times that we get a difference of 0. Now, to get a difference of 1, that means that it would have to be either a 1 and a 2, or a 2 and a 1, and a 2 and a 3, or a 3 and a 2. They have to be 1 apart from each other in order to get that difference of 1. Now, you'll kind of see they kind of follow this diagonal. They follow right outside of our values. So let's see, I have 1, 2, 3, 4. I'm circling all the numbers that the 2 numbers are in there are 1 apart from each other. That one works, that one works, that one and that one, and that one and that one. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a difference of 1 has a frequency of 10. That happens 10 times in my chart. Okay. Now, a difference of 2. That would be 3 and 1, 4 and 2, 5 and 3, 6 and 4. And the flipped versions of those, 1 and 3, 2 and 4, etc. So how many have I got there? 1, 2, 3, 4, 5, 6, 7, 8. And then, let's see, trying to use some different colors here for you. 3, 4 and 1, 5 and 2, 6 and 3. That gets me 3. Hopefully you're recognizing a pattern here. I get 6 possibilities right there. A difference of 4 would be those ones. There are 4 of those. And then finally, a difference of 5, which is my biggest difference that I can possibly have, only happens when I have a 6 and a 1 and a 1 and a 6. That happens 2 times. So, what do we do with all that information? Well, let's set up some probability fractions. We know that in this total chart there are 36 possibilities. Getting a difference of 0 results in 6 of those. So 6 out of our 36 possibilities give us a difference of 0. That reduces to 1/6. This one, to have a difference of 1, our frequency is 10. That means 10 out of the 36 possibilities in that chart give us that difference. If I reduce 10 over 36, I get 5 over 18. Here I have 8 over 36. That reduces to 2/9. This one would be 6 out of 36, which reduces to 1/6. 4 out of 36, and that reduces to 1/9. And finally, 2 out of 36 reduces to 1/18. Okay, so now we're going to take that information and we're going to go ahead and make ourselves a histogram. So my histogram, I'm actually going to use the non-reduced forms of these fractions. The reason is because they all have a common denominator. They're going to be easier to compare than the ones that don't have a common denominator. So these would be my answers if I was asking for the probability, because we do need to reduce our answers. But as far as graphing, we want to have some common ground. So I'm going to go, I'm going to go ahead and call this first line 236. And then the second one would be 436, 636, 836, 1036, and I don't think I have anything higher than 10. No, so I should be good there. So let's see, the probability, or I'm sorry, on this axis I'm going to write the differences. So I'm going to say a difference of 0. You know what, let's put 0 on the x-axis. There would be 0. I'm going to call this first one a difference of 1. Now I'm going to do the solid lines, not the dotted lines. So let's not worry about labeling the dotted lines. That's just going to kind of help us set up our bars when we actually draw the histogram. So there's 1, 2, 3, 4, 5. Do I need to keep going? No, because the only possibilities are 0 through 5 for the differences. So, what was the probability that I rolled a difference of 0? Well, that was 6 out of 36. So to roll a 0, 6 over 36, now they have these lines here to kind of show me how wide my bar should be for that particular value. So there's my 6 out of 36. Now, I'm going to take the probability of a 1. That would be 10 out of 36. So that box is going to be up here. And you notice what I'm doing is I'm just centering my bars over the values at the bottom. So they're just centered over those. Let's see. I'll use this one. Probability of getting a difference of 2 was 8 out of 36. So there would be my bar there. Probability of getting a 3 was 6 out of 36. So there's my bar. Probability of getting a 4 was 4 out of 36. Oops, too far. Right there. And then finally, the probability of getting a 5 was 2 out of 36. So that's what my histogram looks like in general there. It does look like it's a little bit skewed. I would say it's a little bit skewed right because it looks like there's a little bit of a tail there. Not horribly skewed though. So, okay, so there's my probability distribution. Now let's talk about the probability of, actually let's come back up here because we got to talk about these. There are two ways to show the distribution of the probabilities for rolling one six-sided die. So not the two that we did over here, but just one. Both have probability on the vertical axis. So here, right here, I think there's a typo. I think that should say number. I think there might also be there. You don't need that right there. So the probability of rolling a 1 would be 1/6. The probability of rolling a 2 would be 1 out of the 6 sides. 3 would be 1 over 6. 4 would be 1 over 6. 5 would be 1 over 6. 6 would be 1 over 6. From what we learned in our last lesson, we would say that this is a very uniform distribution. Now, here the first bin goes from the y-axis over to 1. So rather than the 1 being centered like I had it there, it's actually on the right side, but it's referring to everything in that bin. Our book uses it that way. Oh, sorry, no, our book uses it the other way. Sometimes you will see them like this, where the number is at the end of the bin. Sometimes you will see it like I did the histogram over here, where the number is in the middle of the bin. This is the way our book uses. So when you're looking at your homework, you may see it a little bit different like that. So just compare those two and make sure that you follow those. Okay? All right, the last little bit is down here. I'm going to start over here. The probability of having multiple events happen. So for example, the probability of A then B is equal to the probability of A times the probability of B. And that's a formula you're going to want to know. So what does that mean? That means if you roll a die if you roll 2 dice and then you roll them again, so you're rolling 2 dice, picking them up off the table and rolling them a second time. The probability that you get a difference of 1 the first time, and I know that probability from up here, and then it says 2 times in a row. So the probability of the first one being a difference of 1 is 5 over 18, correct? If I had my second roll have the same thing, meaning that the second one also had a difference of 1, that's another 5/18 probability. So what's the probability that that happened 2 times in a row? Well, if I rolled a difference of 1 and then another difference of 1, I take the first probability of 5/18 and I multiply it by the second probability of 5/18. That gets me 25 over 324. That is the probability of rolling a difference of 1 2 times in a row. Okay? So let's go back to our single die. We have our double on this side, single on this side. Find the probability of a difference of at least 4. Now this one's different. This is not one thing and then another thing happening. This means, I like to think about this as an OR statement. This means I could roll up the, I'm sorry, I have to add my probability. So that means I have to take the probability of rolling a 4 plus the probability of rolling a 5. That would be at least a 4. Plus the probability of rolling a 6. Right? So that would be at least a 4 means 4, 5, and 6. Well, the probability of rolling a 4 is, I'm sorry, this is still on the doubles. I thought it was on the singles. Let me go back a minute. Ignore this. Actually, going to pause for just, okay, I think I got it all straight here. So the probability of rolling, this is about the differences still. Probability of rolling at least a 4 means that you could have the probability of rolling a difference of 4 and the probability, or I should say the probability of rolling a 5. Well, the probability of rolling a 4 was 4 over 36, and rolling a 5 is 2 over 36. Notice I didn't use the reduced forms of the fractions again because if I'm adding fractions, I need that common denominator anyways. That gives me 6 over 36, which means the total probability there is 1/6. The probability of rolling at most 4, that means everything below 4 and including 4. So probability of rolling a difference of 0 and 1 and 2 and 3 and 4. So we're going to add all these up. 6 over 36 for 0, 10 over 36 for 1, 8 over 36 for 2, 6 over 36 for 3, and 4 over 36 for 4. It gives me a grand total of 34 over 36, which reduces to 17 over 18. Okay, now the probability of an even difference, that would be 0, 2, and 4. Those are my only even possibilities. So the probability of rolling a 0 difference, that would be 6 out of 36. Of a 2 difference, that would be our 8 out of 36. And our 4 difference is the 4 out of 36. And that ends up giving me 18 out of 36, which is 1/2. And hopefully that's kind of to be expected because half the time you would get an even number and then half the time you would get an odd number because that makes up 50% of your possibilities. So, again, if you have 2 things happening in a row, rolling one thing once and then rolling it again, we have to multiply. If you are just talking about one roll and you want the probability of rolling, certain different things, you need to add those possibilities together. Now, your homework tonight is in the textbook. It's page 807, numbers 1 through 4. I'm going to be passing out some data for you. When you get to number 3, there's information you need to have. You need to be able to have some data to go over to be able to answer number 3. So you're going to get this in class today. And if you're not in class today, then there's your picture of what you need right there. But your homework is page 807, numbers 1 through 4. Have fun!